Hello, and this lesson is going to be on the mole and volume. So we've discussed the mole and the representative particle. We've discussed the mole with molecular mass. This time we're going to talk about how the volume of a gas is going to change based on a change with temperature or pressure. So usually the volume of a gas is measured at STP, which is standard temperature and pressure. And those normal values are 0 degrees Celsius for standard temperature, and standard pressure is usually going to be 1 atm, or 1 atmosphere. And at STP, at standard temperature and pressure, 1 mole of a gas is going to occupy a volume of 22.4 liters all the time. 1 mole equals 22.4 liters, just like 1 mole equals Avogadro's number, 6.02 times 10 to the 23rd, just like 1 mole equals the molecular mass of a compound. So mole is our common unit here. So this is called the molar volume of a gas because it's 1 mole is 22.4 liters. Remember, 1 mole of any substance, Avogadro's number. So 22.4 liters of a substance is going to contain 6.02 times 10 to the 23rd particles of that gas. Now, 22.4 liters of one gas is not going to have the same mass as 22.4 liters of another gas at STP. Why? Everything has its own molecular mass. 1 mole equals the molecular mass of that substance. So the 22.4 liters is going to equal 1 mole, but that doesn't mean that they're going to have the exact same mass. So if you're going from moles to liters, remember what you want goes where? On top. So, want over have. So if we have moles and we're trying to get to liters, liters is going to be in the numerator. Liters is going to go on top. See our moles over moles, so that our moles unit cancels. We are left with liters, which is what we are trying to get to. Now, if you're going in the reverse and you have liters and you want moles, then your mole is going to be in the numerator. That is not typed correctly. This should say liters right here. Apologize for that. So that should be however many liters you've been given in the problem times 1 mole over 22.4 liters. So if we look at some examples, our first example here, how many liters are in 23 moles of carbon dioxide gas? So we are starting with 23 moles, and we're trying to get to what? Trying to get to liters. Right there. So we're going to put liters in our numerator. Now, 1 mole is going to go in our denominator. 1 mole is always equal to how many liters? 22.4. So then we do our math. 23 times 22.4. You're going to watch your sig figs. You can only have 2 sig figs here. So our answer is going to be reported as 520 liters. Now you got 515, but because you can only have 1, 2 sig figs, if you look at what's behind it, 5, that means the 1's going to get rounded up to a 2, so you get 520 liters. Here's another example. I want you to try this one on your own, and we will go over it in class tomorrow. How many moles are in 25 liters of oxygen gas? Set this one up, practice this one on your own. Now, in this lesson, we also need to discuss mixed moles. So this is where you're trying to get from not just moles to liters, but say liters to mass, or Avogadro's number to mass. So you're going to go from one of the other units to another, not strictly moles. So this is where our mole roadmap comes in handy. You see the mole is right here in the center. Here is our mole. Remember, that is our common unit, and everybody else is out to the side. So if you're traveling from mole to volume, drive on the correct side of the road, 22.4 liters is going to be on in the numerator. If you're trying to get from mole to mass, here's mole, here's our mass, molar mass is going to go in the numerator. So if you're trying to get from, say, representative particles to a gas, here's our representative particles, so this is going to be where we start. We're going to drive on the right-hand side of the road, which means you need to divide by Avogadro's number. That brings us to the mole, and we're trying to get to volume. So you're going to use the 22.4 liters there, and that's going to get you to a volume. So you're going to have two steps in these conversions. You're going to use this mole road map to get you from one place to another. Now, you can't use this mole road map on a test or a quiz or the SOL, but you can use it for practice to make sure that you're setting it up correctly. So if we look at an example, they want to know how many molecules are in 345 grams of water. Well, the first thing we have to do is write down what we have been given, and that is 345 grams of water. Okay, so grams. Ding, ding, ding. That means we need to find the molecular mass of the compound. Water, H2O, each hydrogen weighs 1, that's 2, plus the oxygen is 16, water weighs 18 grams. So, moving on with our conversion factors. When you have one unit to another without a mole in your problem, you have to go to your mole first. So this is just like the normal conversions where you have to go to your base unit. Our base unit is going to be the mole. So the first thing we have to do is grams to mole. We want mole. Mole's going to go on top. Trying to get rid of this grams unit right here. So we're going to put grams in the bottom. How many grams are we going to put there? We're going to put our grams of water. Okay? So, 18 grams. Now, do we want moles? No. They asked us to find molecules. So, one more step. Molecules uses whose number? Avogadro's number, which is 6.02 times 10 to the 23rd molecules. Avogadro's number is always equal to 1 mole. So our answer is going to be 345 divided by 18 times Avogadro's number, 6.02 times 10 to the 23rd. For sig figs, we can have how many digits? 3. 1, 2, 3 digits there. So when we report our answer, we are going to report it as 1.15 times 10 to the 25th. And what is our unit going to be? It's going to be molecules, because that's what we're looking for. That's the only thing we're left with. Our moles canceled. Our moles canceled. Our grams canceled. So the only thing we're left with there is the molecule. So our unit is going to be molecules. Try this one on your own, and we will discuss it in class tomorrow. How many grams are in 18.0 liters of carbon dioxide? So solve this one on your own, and we will discuss it in class tomorrow.